Hello friends, welcome back. Hearty welcome to you. As part of integrals, let's look at this problem. We have to find out the integral of square root of 1 plus x square divided by x power 4 dx. Now, we certainly know that we have to take root of 1 plus x square as t. If I am able to do that, then I have, as you understood, I will have x dx 1 plus x square equals to t. If I am able to do, I get 2x dx equals to dt, and this term whatever we have in the denominator is not getting cancelled out, but instead of that it's becoming more complicated. Now I have to convert the numerator in such a way that whatever when I differentiate, it should be able to cancel out the term in the denominator, and we know that happens only when the numerator becomes with a power of negative power. Then if suppose let us say it's like x power minus 3, then we know when I differentiate I get minus 3 by x power 4, something like that. That means I should be able to convert the numerator into negative power. To do that, what we will do, we'll go ahead and divide numerator and denominator by x. Can I write down root of 1 plus x square divided by x divided by x power 4 divided by x. So this will be equal to, if I am able to take that x inside, it will become root of 1 plus x square by x square. Now you will see why I am doing that. Once you are able to see that we are getting negative power there, this is equals to x cube. Now can I write it as square root of 1 plus 1 by x square divided by x cube. Now if you are able to understand, this 1 by x square when I differentiate will give me x cube, which can be cancelled out, and the problem becomes pretty simple. So that's the idea. So whenever we have a problem where we directly take this, it's not cancelling out the denominator, then we have to think that how we have to change this into negative power, like x power minus 2 here, by dividing appropriately so that the dx will cancel out the denominator. So let's move to the next step. Now I can go ahead and write down 1 plus 1 by x square equals to t. So when I differentiate, I get x power minus 2, that is minus 2 divided by x cube dx equals to dt. So, or can I say that dx by x cube, which I have already with me, is equals to minus 1 by 2 into dt. Let's go ahead and convert this into t now. I have root of 1 plus 1 by x square, that is square root of t, and I know dx by x cube equals to minus 1 by 2 dt. Can I write down minus 1 by 2 dt? Now this is equals to minus 1 by 2. Integral of t power 1 by 2 is 2 by 3 t power 3 by 2. 2 cancels, you get minus 1 by 3 t power 3 by 2. But what is our t? That is minus 1 by 3. T is 1 plus 1 by x square whole to the power of 3 by 2 plus c. So that's how we can solve this problem. We can solve this. Suppose let us say that we are not getting the idea that we have to divide with x, then you can go to trigonometric substitution and try to solve this problem also. Let us see how we can do that with trigonometric substitution. Since I see square root of 1 plus x square, now I have to look for trigonometric identities which will take out that square root and will give me a value. Safely I can take x equals to tan theta. I can take x equals to tan theta, then 1 plus x square will be secant square theta, then square root of 1 plus x square will be secant theta. That is pretty good to start with. And we also know dx equals to secant square theta d theta. Now let's go ahead and substitute this. We will have root of 1 plus x square, that is secant theta, divided by x power 4, that is tan power 4 theta. Dx is secant square theta d theta. Now can I write it as integral of secant cube theta d theta divided by tan power 4 theta. Now we will go to the most general part. What we do always convert them into sine and cos. I have 1 by cos cube theta divided by sine to the power of 4 theta by cos to the power of 4 theta d theta, which is equals to, after simplification, you get cos theta divided by sine to the power of 4 theta d theta. Now what we will do, we try to simplify this. So we will take sine theta equal to t, because we see that cos theta d theta equal to dt. So that will simplify the things. So can I write down cos theta d theta equal to dt? Now what will happen? So once we substitute that, we will have integral of cos theta d theta is dt, cos theta d theta is dt divided by sine to the power of 4 theta is t power 4. dt by t power 4 is equals to t power minus 4 dt. Now is it nothing but equals to t power minus 4 plus 1 divided by minus 4 plus 1, or can I say minus 1 by 3 t cube plus c? Now but what is our t? Our t is sine theta, that's minus 1 by 3 sine cube theta plus c. But what is sine theta according to us? So to understand that, we go to the triangle. Suppose I'll start from here. I have x equals to tan theta. If I look from here, tan theta is opposite by adjacent, x divided by 1. This will become root of 1 plus x square by Pythagoras theorem. Then what is our sine theta? Sine theta is x by root of 1 plus x square. So now we have minus here, sine power minus 3 theta. So can I write it as minus 1 by 3 minus 3, I will write down there, plus c. What is my sine theta? Sine theta is x by root of 1 plus x square. Now we can leave it like this, or we can simplify that as minus 1 by 3 square root of x square by 1 plus x square whole to the power of minus 3 plus c, or we can also write it as minus 1 by 3 square root of 1 plus 1 by x square whole to the power of 3, or I can write down by taking out the root there. I can write it as, I can take out this root, I can take out this, and I can write it as 1 plus 1 by x square whole to the power of 3 by 2. So that's the solution what we got earlier, that is minus 1 by 3 into 1 plus 1 by x square whole to the power of 3 by 2. So two ways of solving this problem. One, we can see that if I take root of 1 plus x square, the denominator is not cancelling. So if I want to get, when I do differentiation, I have to get the value in denominator. That means the numerator should be changed to negative powers. To change it to negative powers, we have divided that with x. So that makes it 1 plus 1 by x square. 1 by x square, we are sure that it will give us minus 2 by x cube. So when we divided with x, when we differentiate, this term denominator got cancelled. So that's how it became simple. Suppose it is not striking you that you have to do that, you can safely take x equals to tan theta, go back to trigonometry for help, and substitute root of 1 plus x square is secant theta. Then substitute appropriate values. You should be able to integrate it and find out the same answer, that is minus 1 by 3 1 plus 1 by x square whole to the power of 3 by 2, and at the end plus constant term. So that's one interesting example which I thought of sharing with you. We'll continue with more problems as part of integrals.